Hi guys, welcome to DHARANI'S Max channel. Before going into this video, please like and subscribe for more videos. So you know that we have completed learning till exercise 1.2, and in this video we are going to see exercise 1.3, that is from 5th sum to 6th sum. So let's see what are those. What can the maximum number of digits be in the repeating block of digits in the decimal expansion of 1 by 7? Perform the division to check your answer. So we have to perform a division, normal division, to get our answer. What should be the answer obtained according to this question is, we have to see the maximum number of digits in the repeating block. So where we can see the repeating blocks, that is in the quotient. So in a non-terminating decimal expansion, we can see repeating blocks and they can be represented with bar, as you can see here also with bar. So it's the same method we are going to try here, and we have to find the maximum number of digits in the repeating block. So when we divide 1 by 17, we can get the answer as 058823529411764705. So we have to add a 0 as it is a smaller number, then we have to add a point, you know very well how it is so. Then again we have to add a 0 as it is a smaller number, then we get 100. 17 into 5, 85. 100 minus 85, we get 15. 15 we have to add a 0. 17 into 8, 136. So 150 minus 136, we get 14. 14 we have to add a 0. Then 17 into 8, again 8, 136. 140 minus 136, you know very well, it is 4. 4 we have to add a 0. Then we can't get 40 in the 17 table, so we have to take a lesser number, that is only we are going to take. So when a number is larger and if that number is not divisible in a particular table, we have to take the lesser number, as you know very well, divisions. So that is what I am going to apply here. So 40, 17 into 2, 34. 40 minus 34, you get 6. 6 we have to add a 0. Then we can get 51, that is 17 into 3, 51. 60 minus 51, we get 9. 9 we have to add a 0. So in 17 into 5, you get 85. 90 minus 85 is equal to 5. 5 we have to add a 0. 50. Then 17 into 2, 34. 50 minus 34 is equal to 16. 16 we have to add a 0, then we get 160. So when we do like that, we can get 17 into 9, 153. So 160 minus 153, if we subtract, we get 7, and we have to add a 0. So 17 into 4, 68. 70 minus 68, we get 2. 2 is a smaller number, we have to add a 0, so we get 20, and 20 is not divisible in 17 tables. We are going to take the lesser number. 17 into 1, 17. 20 minus 17, we get 3. This step is repeated. Then 3, we get 3 now. So 3 we have to add a 0. When we add 17 into 1 should be added, that is 17. 30 minus 17, we get 13. So 13 is a smaller number, we have to add a 0. So 17 into 7, the 130 minus 119, we get 11. 11 is a smaller number, we have to add a 0. So when we do like that, 17 into 6, 102. So 110 minus 102, we get 8. 8 is a smaller number, we have to add a 0. Then when we add a 0, we can get 80. So 80 minus 68, that is 16 into 4, we get 68. 80 minus 68, we get 12. So 12, again we have to add a 0, as it is a smaller number, you know very well. So we have to take 17 into 7, 119. So when we take like that, 120 minus 119 is equal to 1. So 17 into 0, that is why we are having 0, as 1 is a smaller number, we have to add a 0. Again we can get 10, that is also a smaller number, again we have to add a 0. So when we are adding twice zeros, we have to add 1 0 in the quotient. So 17 into 5, 85. 100 minus 85, we can get 15. Do you notice that the first step and the steps are same? So here you can get 1, here also 1, The second step 15, here also 15. So this shows that this decimal expansion is going to be repeating, and the maximum number of digits in the repeating blocks are 16. So you can take the quotient separately, and if you count you can get the number 16. That is 1 2 after decimal only we have to count. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. So we get 16 digits in the quotient, so that is the answer. So next is the question 6. So let's see the question 6 now. Look at several examples of rational numbers in the form p by q, q is not equal to 0, where p and q are integers with no factors other than 1 and having terminating decimal representation expansion. That is, they should have terminating decimal expansion. Can you guess what property q must satisfy? So we have to according to this example, they have given the example. So where the factors, that is common factors, where q and p are integers with no common factors other than 1. So having terminating decimal expansion, that is, these are terminating decimal expansion. Can you guess what property q must satisfy? So we are going to take here only the denominator, and we are going to express in the expanded form. So when we express in the expanded form, we can get the numbers so that the q can satisfy those numbers, and we can find the answer out of it. So let us take 1 by 2. We are going to take some terminating decimal expansion. 1 by 2, 1 by 4, 7 by 8, 3 by 37 by 25, 8 by 125, 17 by 20, 31 by 60, etc. Which has terminating decimal expansion. Why we are taking only terminating decimal expansion? As they have given in the question that other than 1 and having terminating decimal representation, so we have to take that only. So 1 by 2 we cannot divide further, because 1 by 2 into 1 we can say, but anyhow it is going to be remain same. So 1 by 4, next number 1 by 4. So numerator we should not we should keep it the same, and the denominator only we have to take it, as they have given here q. So denominator can be divided as 2 into 2 into 1. So we can say 2 into 2 4, 4 into 1 4. So next is 7 by 8. 7 it should be same. So the denominator is 2 into 2 into 2 into 1. So we have to express the particular denominator in the expanded form, okay, only with the prime factors. So 2 into 2 into 2 into 1, we get 8. 8 2 into 2 4, 4 into 2 8, 8 into 1 we get 8. 37, the numerator should be same. The denominator 25 can be separated as 5 into 5 into 1. 5 into 5 25, 25 into 1 we get 25. 8 into 128 by 125. So 8 should remain same. Then denominator 5 into 5 25, 25 into 5 125, 125 into 5 we can get 125. So 17 should remain the same. 20 we have to take, and 2 into 2 4, 4 into 5 20, 5 and 20 into 1 we get 20. 31 must remain the same. 16, 2 into 2 4, 4 into 2 8, 8 into 2 16, 16 into 1 we get 16. So now we have expanded all in expanded form. Here the denominator is either 2. Here we can see is either 2 or power of 2 or 5 or power of both, or both, okay, or power of 5 or both. So hence p by q is either 2, that is just 2, or power of 2, that is power of 2 here, or 5, just 5, or power of 5. just power of 5 or both it can be. Okay, so the denominator, the q can satisfy these methods. So hope you understood, I think. Thanks for watching. Subscribe, like, comment, share. See you in the next video.